Hey everyone, welcome to part 2 of our solving quadratic equations by factorizing video. Now you may have noticed that in the previous video, the quadratic equations we were working through solving and these expressions on the left hand side, they often had, well actually in every case, only two terms. It'd be something like, I don't know, x squared plus 4x equals 0. We solved one like this, or x squared minus 9 equals 0. Now, if you've watched the series on quadratic expressions, you may remember this general form for all quadratic expressions. Now, in this particular case here, we're missing our c term. So we can think of our c term as being 0. So for this guy here, my c is 0. So it doesn't exist here. And in this case, my x squared minus 9, there was no x term, which implies that the coefficient of x must be 0, because 0 times x equals 0. There's a non-existent x term here. So in this guy, my coefficient b in my general quadratic layout of my quadratic expressions is 0. So we haven't dealt with the hardest types of quadratic expressions yet and solving these as equations. We haven't looked at when we have an a coefficient, a b coefficient, and a constant. We haven't worked yet at solving when we have all three here. And that's what we're going to be doing in this video. Now, I'm going to just redirect you guys to something we've been talking about which has allowed us to solve all of these equations so far, and that is the null factor law. And once again, in this video, we are still going to be factorizing these quadratic expressions as well as applying the null factor law to solve the actual equations. So let's just jump straight into some examples and we'll work through how we can do something like this. Okay, so my first question is I have x squared plus 7x plus 12 equals 0. Now, this looks scarier, but the process is still the same. We want a binomial product, or any product for that matter, so we can apply the null factor law. I'll write this as NFL, so we can apply the null factor law. Okay, so that means we want to factorize this guy on the left here into a binomial product. And we want to factorize this quadratic. And for those of you who have watched my videos on factorizing quadratic expressions, the techniques we learned there are going to be very useful. Now I'm recording this video assuming you are up to scratch with factorizing quadratics. So if you're not, please pause the video here and you can watch some of my older ones to get you up to speed. But we remember from our previous work on factorizing quadratic expressions is that the two factors we get, so the guys in here, these terms, are two numbers that sum together to give me this coefficient and multiply together to give me my constant here. So I want to pick those numbers and find what those numbers could be in order to factorize this quadratic expression here. So I want to find my product, sum. Well, I want to list my product, my sum, and then find the two factors here for my expression on the left here. Now, my product is going to be 12 My sum is 7. And I want to find my factors. So I want to think of two numbers that add to give me 7, but multiply to give me 12. Now, take a moment to pause this and have a go at it on your own if you'd like. But the factors are going to be 3 and 4. 3 and 4 multiply to give me 12. So that's good. And they add to give me 7. So those are going to be my factors. So if I want to factorize my x squared plus 7x plus 12, this is going to become, now please refer to the previous video if this is new to you. I'm going to do this the longer way just for the first example and then the shorter way for the next one. I get the step before. Now I'm factorizing the quadratic expression. And I'm going to factorize this by grouping in pairs. So my first pair here, I'm going to take out the common factor of x. And I have x plus 3. And in my next pair, I'm going to take out the common factor of 4. And I get x plus 3 again. Now, x plus 3 is a common factor to both of these expressions. So I'm going to pull that out the front. And what goes in my brackets is what I'm left over, what x plus 3 is multiplying by in both cases. So I get x plus 4. So I have factorized my expression on the left-hand side of the equation. So now, instead of writing it like this, where we can't do anything with it to solve the equation, I can write on the left-hand side my binomial product, which lets me use the null factor law. So this is going to become x plus 3, x plus 4 equals to 0. And applying the null factor law, I want to solve each of these particular expressions to find a value of x that makes each expression 0. Now, I know I sound like a broken record here, but because we have a product, we can use the null factor law. When we find the two cases where each is 0, 0 times by anything else gives me an answer of 0. So these will be solutions to my quadratic equation. So I have my first expression, x plus 3. I want to find a value of x that makes this x plus 3 equal to 0. And my second expression, I want a value of x that makes x plus 4 as an expression equal to 0. Now, I'm going to work through this a bit quicker because we've done these techniques a lot in the last few videos. So I'm going to solve each of these equations, subtracting 3 from both sides here, subtracting 4 from both sides here. And I get left with x on its own equaling to -3 and x equaling to -4 here. So these are the two solutions to my quadratic equation. And I get there by first making this guy into some type of product. And it ends up being a binomial product down here when we actually factorize. So that is the process that we're going to use for all of these questions. Now, I'll try to go through them a little bit quicker because I've already given the explanation at the start. But what you can do as well, once we get the answers, you can just check they're right by subbing both of those in separately to your expression on the left-hand side and see if we end up getting 0, if we end up getting solutions to this equation. Now, question 2. I have x squared minus 2x minus 8 equals 0. So I want to get this to a binomial product on the left-hand side. So that's going to require me to factorize this expression, x squared minus 2x minus 8, And I'm going to do this using our PSF method that we have talked about previously. So I want two numbers that multiply to give me -8, add to give me -2. Now, pause the video, feel free to have a go at this. But I'm going to get -4 and +2 as my factors here. So when I end up factorizing this guy, my factors are going to go here and here. So I get -4 and +2 here. So now, instead of this expression, I'm going to write the exact same expression, just factorized, this one, in place of it. So I'm left with x minus 4, x plus 2 equals to 0. And now I can use my null factor law because these are binomial products. They are timesing by one another. So we can find a way to make each of these, to find a value of x to make each of these expressions 0. We find solutions to my quadratic equation. So I want to find a value of x that makes x minus 4 equal to 0 and a value of x that makes x plus 2 equal to 0. And I can do this by just solving these equations. And I get x on its own here, and 0 plus 4 gives me +4 here. And x on its own here, 0 minus 2 gives me -2. So these are the solutions to my quadratic equation. Now let's do let's do 2 more questions here. Let's do this question here. So we'll go x squared equals 8x minus 15. Now, to solve this, remember, with solving any quadratic equation, I want all of my terms on one side equaling to 0. This is the standard form of quadratic equations. So I want to get both these guys on the right on the same side as my x squared to make my life easier. So my +8, I can get it to the other side by subtracting 8x, sorry, my +8x, and my -15, I can get to the other side by adding 15. Adding 15 to -15 gives me 0. Subtracting 8x from 8x gives me 0. So once I get everything on the left-hand side, I wind up with 0 on the right-hand side. Now I want to get a binomial product on the left, and I'm going to do this by considering the factors here. So my factors will need to times together to give me 15 and add to give me -8. And therefore my factors are going to be, feel free to pause the video, have a go on your own. I have a negative number here, which means that at least one of my numbers has to be negative, but I have a positive product, so both of my numbers have to be negative. So I'm going to get -3 and -5 here. And these factors are going to go, into my binomial product that I factorize to get. So I get x minus 3, x minus 5 here. And then I can rewrite my equation using the binomial product. X minus 3, x minus 5 equals to 0. Now these are products, so I can just find the values of x that make both expressions, either x minus 3 equal to 0 or x minus 5 equal to 0. Okay. And from here, we already know how to do this. We've done plenty of examples like this. I'm just solving the equation now. And I wind up with x equals 3, x equals 5. Okay, let's do one more example just to practice. And this is a special case. This is quite a special example here, because in all of the questions we've been doing so far, we've been getting two solutions. Now we'll see that sometimes we actually don't always get two solutions. Now this is one case here. Now I have my expression on the left. I'm going to factorize this again using my PSF method. So I want a product of 16, a sum of -8, and my two factors are going to be -4 and -4. So I have two of the same factors, because -4 minus 4 gives me -8, or -4 plus -4 gives me -8. -4 times -4 gives me 16. So my factorized thing here is going to be x minus 4, x minus 4. Interesting. Now, let's take a look at how solving this is going to look. 4 equals 0. Now, you can see that these two things are identical. So if we go about solving this, in both cases, let's actually just do one arrow, because I'm going to get the same thing for both. Both of these are going to give me x minus 4. So to solve this, my only solution here, I have actually still two solutions, because I have 1, 2, but the solutions are the same. They are the exact same. So this is going to be x equals 4 as my answer. Now the reason it's like this is a special type of quadratic expression that we looked at in our previous course on quadratic expressions. This is what we call a perfect square, because I have x minus 4 times itself. So another way we can write this is my expression, x squared minus 8x plus 16, this factorizes to x minus 4 all squared. And this is only going to give me one solution for x. I'll show you. Say we did this a different way. Let's use another method here. Let's say instead of writing it like this and just figuring out that we had the same solution for both, why don't I take the square root of both sides here? Because that's going to kill this square here, and it's not going to affect the right-hand side, because the square root of 0 is still going to be 0. And this leaves me with x minus 4 equals 0, and I'm left at the same step as up here. I only have actually one solution. So when I go through and solve this, I wind up with x equals 4 as my only solution. So now we have covered the entire spectrum of these quadratic equations. We've covered perfect squares, difference of two squares in the previous video, as well as quadratic equations in the general form of a quadratic, in which we have all three of these terms. We have my coefficient in front of x squared, a coefficient in front of x, and a constant c. And these techniques, you can see we're always doing it in the same way. We're always factorizing my left-hand side to get some kind of product, and then we are applying the null factor law. And that is how we can solve all types of quadratic equations by factorizing. Thank you so much for joining me, guys. I'll catch you in the next video.